So the next subject covered in chapter 4 is encapsulation, which again is revision, because I think we briefly looked at it in chapter 1, and we've been practicing it right from the start. We see it very clearly in this animal package here, where we've got we're saying at this level this name and type are private, so nothing else is allowed to touch them. They're encapsulated, they're protected. The only way you can get hold of them is by public methods that we'll provide to you, like these. So via this constructor here, so remember this is a constructor for animal. You can tell it's a constructor because A, it has the name of what you're constructing, and B, it doesn't have a return type. So a bit of revision: if you had that in there now, that may look like a constructor, but it's not. It's a method because it's got a return type, but that is a genuine constructor. But anyway, through this constructor you can access those variables, but so the object is controlling how you access these variables through its own public methods. Again, getters and setters are here. So that's the essence of encapsulation. It's a very important, like, fundamental part of object-oriented programming, and we see it again here. So this class is really just going to demonstrate, well, A, how it works, which we've already seen, but B, like the conventions around it. So we have a couple of instance members here. Again, I use these words interchangeably, really. Fields, members, parameters, members, variables, whatever, it always means the same thing. Basically, variable declarations you have in your class. So we've got a string and a boolean here, playing and name. So this method, so it's really about what follows the Java conventions, and we call this javabeans convention because classic objects that maintain state, i.e. they have members like this and then getters and setters to access them, are called javabeans. That's just the name they've evolved to have. And so this follows javabeans conventions, because we've got a variable called playing, and we're saying get playing will return the value of that. So that get camel case on that with the exact same name as the variable, that follows javabeans conventions. If you did that, it doesn't anymore. You just have to, it's purely the name. You have to follow the conventions. The reason this has become increasingly important is that a lot of what we do in Java now, we get the sort of heavy lifting done behind the scenes by some sort of framework like Spring or Camel or something like that. These common frameworks that are used, and you'll usually configure them with names of your classes and things, and they'll go and do the rest. And what they depend on to do their stuff is they depend on the fact that you've put a getter and setter there conforming to javabeans conventions. So say if I had called that value, I could say to myself, well, it doesn't conform to javabeans conventions, but I don't care, because in all the programs I write, I'm just going to use get playing value, so it won't matter. It's only some academic thing that it doesn't conform to javabeans conventions. But there is more to it than that. If you try to plug this into a program, a framework like Spring, it came to that object, it would say, oh, hang on a minute, there's no getter, there's no get playing in this class. I can't, you'd have some sort of Spring configuration error. So you should always conform exactly to javabeans conventions if you're using those frameworks and things, and in general anyway. So again, set playing, that conforms as well, exactly the same rules. Set playing, typically as well, what you pass in, you just give it exactly the same name as the variable that you're setting, like that. So what you have to be careful of here is that even though it looks fine, it's completely futile, because what it does, it's setting itself to itself. We have to do this, and then you'll see that, like, the purple colouring tells you it's actually this one. So this means this is a very important Java keyword. It means this instance. So that's why the use of the word this in a static method means absolutely nothing, and you get a compiler error if you do that. This means in this particular instance, so the value of the playing variable in this instance, set it to the one that you're passing in. It's if you did this, some people get round that sort of issue by prefixing it with a p, meaning that means parameter playing. So if you did this now, you could theoretically take that off, because it knows there's no other alternative. It knows it's that one there. So you might want to do that, but just the convention is to have them the same, and to use the this keyword to make it absolutely clear that this one is the instance variable here, and this one is the one that's coming from the method. So this one also follows javabeans conventions. It's doing the same as this. So get playing, only in the case of a Boolean variable you can say is playing, because you're kind of turning it into a question, because a Boolean is a true or a false. So this imagine this is a person, either they're playing or they're not. So you can say, imagine this is a person called Jack. You can say Jack is playing. It's like asking a question, and you'll either get a true or false back. So that conforms, and so does that, even though they're doing the same thing. It's up to you which one you do. This one doesn't, because you're just using this. You haven't got get in there. It's a get. It's doing the same as a getter, but it doesn't conform to the convention of having get name in there. And so update name follow. Yeah. So again, we just say you might think that you might prefer to, rather than saying set name, as it was set playing there, or set name, you might personally prefer update name, but it doesn't conform to the javabeans convention, and it's not advised to do that. It's always best to call it set, because that's what all fellow developers and frameworks and things are expecting. That has to be capitalized. You see that these all compile, but that has to be capitalized to conform there, so that doesn't work. And so that's all the javabeans conventions. Now they tie into encapsulation. Just one other final thing to look at on this, which covers encapsulation and why we use it, but also it touches on immutability, which is connected to encapsulation. So what we've got in the animal class here, as I said, we're starting to build up this like zoo of animals, but most of them are fairly nondescript like that, but there's a few in there that do special things, and this swan one is another one. This swan one is a special case with extra methods that are used to demonstrate encapsulation. So here we go. We've got our classic. A swan has a number of eggs. We've got a getter and setter for the number of eggs. So classic Java bean. That it's just doing that because it extends animal. An animal is an abstract class which insists that you override eat, because it's abstract in itself. So you can't have a concrete class with any abstract methods. That's just a nod towards abstract classes, which we'll do soon, but it's just a little aside there. So we can ignore that for now, but just that's why it's there. So classic Java bean there, protect a private variable and getters and setters. So what we could do is we could do in the encapsulation one, we could say, yeah, give me a new swan, and set the number of eggs to -1. Well, okay, first thing, we can't do that. We can't. We're trying to access the variable directly, but it's private, so we can't do that. So that's standard of encapsulation. But we can do it this way. We can set it through the setter, because the setter is there to allow the access to those private members. So we're doing that, and then we're just going to print the value of that. So just run that class. So what we're saying is that this swan has -1 eggs. Now, for what we know of swans and the biological world, that's impossible. That's impossible to have at -1 eggs. You could have 0, but not -1. So this is where we can use encapsulation to protect us. And so what we can do is, let's get rid of the bog standard setter there and get another one, but it's named exactly the same because it conforms to the javabeans conventions. But this time it's going to say, well, if you give me a number of eggs that's less than, as long as the number of eggs is 0 or more, fine, we'll set it. We'll do what that one was doing. But if not, throw an illegal argument exception. The eggs must not be negative. So again, this demonstrates how encapsulation can be used to sanity check and protect your members there. This also shows how we can, shows how we use these if statements and things to guard, like to make things defensive, which is typically what they're used to use for. So go in that and run again now. So we're attempting to set that number of eggs to -1. But now it's saying no, we can't do that. It's a legal argument exception. Eggs must not be negative. So it's stopped us doing that. And the final thing to show is immutability. So we talked about a string being immutable, dates being immutable. If you there was another class we looked at before, which was immutable. Oh, well, local dates we looked at. There's various reasons why you may or may not want to make a class immutable, which are kind of beyond the scope of the exam that we're working towards. But whatever the reasons are, the actual way of doing it is actually quite simple. So we've got immutable swan here. So we had swan there, which is just a normal animal, but it's got this defensive set method in it, setter method here. So immutable swan now. What we've done, it hasn't got any setter methods at all. So it's got a get. So you have to create it immediately with the number of eggs in the constructor. This private number of eggs here, and you can get it if you want to get it and display it. That's fine, but you can't set it. You can't set anything on it. So once that's set, there's no way of resetting it again. There's no way of changing it. So that is immutable. So actually implementing immutability is quite simple. You just you make sure there aren't any setters or mutator methods that can actually fiddle with it. So let's go back to the demonstration again. So immutable swan now equals new immutable swan, and we tell it straight up the number of eggs is 4. If we try and do this with a no arguments constructor, it doesn't compile because it doesn't provide a no arguments constructor, because it's trying to use common sense. It's trying to say no, you have to tell me up front, because if you don't give me this up front, nothing will ever be able to change it. And what you could do, we haven't bothered to do, but what you could do is you could, if we were trying to pass that -1 in there like we did here, you could make that constructor have that same logic that we had in the other one. I just haven't bothered to do it, just because it's just a small demonstration class, but we could do that. And this, where it literally says number eggs there, by the way, this is just the IDE IntelliJ trying to help us, and it does help us, but it can also be confusing in demonstrations, because we put 4 there. It's telling us that the variable that you're passing that to is called number of eggs. It almost looks in a demonstration context, in a classroom context, as though that's part of your code, but it isn't. It's just the IDE trying to be helpful. It's really just the number 4 in there, and I'm even trying to delete it and it won't go away. So
turn that off?
Yes, and it might be an idea to do that if that's confusing to people. Is it confusing? Yeah, it's confusing to people.
No, I think it's useful for me.
Okay.
Maybe if you're a really experienced programmer, it might be less useful, isn't it?
Yeah.
You want the training wheels off sometimes, don't you?
Yeah, that's it. Yeah, I mean, so I was thinking it might be confusing to newer developers, because they might think, oh, actually, that's actually, he's written that there, but which I haven't. But I'll leave it in for now.
On that line there, can you set it to -4 and run it?
On there?
Yeah.
Yeah, you can. You can, because. Which kind of makes a nonsense of it, because you're saying this swan's got -4 eggs.
Yeah, well, Cuckoo could have been along, couldn't he, and swap them.
Yeah, that's true. But on what we've done, the way things stand now, it would allow that. But what we could have done is we could have taken the same approach as we did here, and we could have wrapped this logic in it. Maybe I'll do that ready for next session, actually, just so that you can't do that. So you can't set it to anything negative. But as things stand, you actually can. There we go. So, and this is, and then finally, so you set the number of eggs to 4. What if you want to change it to 3? You can't do it because it's immutable. It doesn't have a setter method. So that's it. So that's basically just demonstrated encapsulation and brought in immutability, because they're sort of related. And we always talk about strings being immutable, dates being immutable, without perhaps knowing what that really means or how it's implemented. And as you can see, it's actually quite simple to implement immutability. You just don't provide any setters, and if there aren't any setters, then nothing anyone else can do about it.